What is sound? It's the vibrations of molecules in the air. It's a pressure wave. Sound takes on many forms, but the kind that we're most familiar with is pressure waves moving through gas.
Sound travels faster through lighter gases like helium,
making our voices sound higher pitched.
When the air is colder or made of heavier gases like sulfur hexafluoride,
sound travels more slowly.
But there's even more to it than that.
Sound can be transmitted through any kind of physical medium. So if you are in a swimming pool, you can still hear sound. That's being transmitted through water. Earthquakes are essentially sound waves being transmitted through the solid earth.
We've all been there, sitting in a darkened theater, completely absorbed by the spectacle unfolding before us. The screen glows with the image of a colossal spaceship, its metallic hull gleaming as it hurtles through the void. Suddenly, disaster strikes. A massive explosion erupts, sending debris flying in every direction. The audience is transfixed, eyes wide, hearts pounding, as the drama plays out in vivid color and sound. The sound design is nothing short of spectacular. A deafening roar fills the theater, shaking the very seats beneath us. The subwoofers rumble, the walls tremble, and for a moment it feels as if we are right there in the midst of the chaos, experiencing the explosion firsthand. The power of cinema lies in its ability to immerse us, to make us feel as though we are part of the story, even if just for a fleeting moment. But what about the reality of space? Would such a cataclysmic event really echo with such ferocity, reverberating through the cosmos as it does in our favorite films? The truth is, space is a very different environment from what we experience here on Earth. In the vacuum of space, there is no air, no atmosphere to carry sound waves. Explosions may look spectacular, but they unfold in utter silence, invisible to the human ear. The reality, as captivating and awe-inspiring as the universe itself, is far more nuanced than Hollywood would have us believe. In the vastness of space, even the most violent events, colliding asteroids, supernovae, or the destruction of a spacecraft, occur in a profound, unbroken silence. The stars shimmer, galaxies swirl, and planets orbit in a cosmic ballet, all without a single sound to mark their passage. In the endless expanse of the universe, silence reigns supreme. For astronauts floating above the Earth, the only sounds are those created within their own suits. Their breath, the hum of machinery, the faint thump of a heartbeat. Beyond the thin shell of their helmets lies a world where sound simply does not exist. It is a silence so complete, so absolute, that it can be both humbling and haunting. This is the true silent cinema of space, a place where the greatest dramas unfold in perfect, eternal quiet.
Places like Mercury and these rocky bodies with no atmospheres would be similar to being in space. There would not be much sound, if any.
With its near-vacuum surface conditions, it might seem like Mercury would be completely devoid of sound. But it's there. Not in the air, but in the rocks. Scientists have found evidence that the planet is seismically active. So if you put your ear against the ground, you might catch the sound of something strange. A Mercury quake.
To understand why space is silent, we must first unravel the mystery of sound itself. Sound, at its core, is a vibration, a rhythmic dance of particles through a medium. Imagine plucking a guitar string. The string vibrates, these vibrations ripple through the air, reaching your ear and triggering the sensation we perceive as sound. Here's the crux of the matter. Sound, as we know it, is not just a mysterious force that appears out of nowhere. It's a physical phenomenon, a vibration that needs something to move through. When you clap your hands, speak, or play an instrument, you're actually causing the molecules around you to vibrate. These vibrations ripple outward, transferring energy from one molecule to the next. And that's what we perceive as sound. But for this to happen, there must be a medium, a substance like air, water, or even a solid object for those vibrations to travel through. Whether it's the air we breathe, the water in the ocean, or the solid ground beneath our feet, all these materials are made up of particles that can transmit sound waves. In air, sound travels as a series of compressions and rarefactions, tiny pushes and pulls between molecules. In water, the process is similar, but the molecules are packed closer together, allowing sound to move even faster. And in solids, where particles are even more tightly bound, sound can travel faster still, sometimes at astonishing speeds. Now let's consider space. Space is not just empty, it's a near-perfect vacuum, an environment almost entirely devoid of matter. Between the stars and planets, there are so few particles that for all practical purposes, there's nothing to carry the vibrations we call sound. Even if you shouted at the top of your lungs, the sound would never reach another person because there's simply nothing there to transmit the vibrations. Without this crucial ingredient, a medium filled with particles, sound simply cannot propagate. This is why in experiments on Earth, when scientists remove the air from a chamber and ring a bell inside, the bell still vibrates. But no sound escapes. The vibrations have nowhere to go, and silence reigns. It's a bit like trying to start a wave in an empty swimming pool. Without water, the wave has no medium to carry it. No matter how hard you try, you can't make ripples in a pool that's bone dry. In the same way, sound cannot travel through the emptiness of space. This is the vacuum of silence, a place where no matter how loud the source, there is only quiet.
Because you have this really dense atmosphere, much denser than Earth's, the sound would tend toward what things sound like when you're underwater. If you could imagine something in between air and water, that kind of density, you're running your hand through that and you would feel that. If you were to just materialize in that environment of 900 degrees Fahrenheit and 100 times our atmospheric pressure, you would first be crushed, and then you would probably just burn up completely.
One thing we do know about Venus is that it has lightning. So you might hear thunder.
It turns out that Venus is one place we have real audio from. In the early 80s, the Soviet lander Venera 14 successfully landed on the surface. It survived for nearly an hour before shutting down. And during that time, it picked up these eerie sounds of the Venusian winds. But what about something more human? What would my voice sound like?
The denser atmosphere would tend to lower the pitch, but the hotter air would act to increase
The speed of sound, making my voice sound higher. It's a strange scene to imagine.
You might be surprised to learn that NASA has released recordings of space sounds sparking curiosity and wonder. However, it's crucial to understand that these are not sounds in the traditional sense. Instead, they're actually the result of a fascinating process of translating electromagnetic data collected by spacecraft into audible signals. Imagine for a moment a radio receiver sitting quietly in a darkened room, its antenna reaching out into the night, searching for signals that are invisible to our eyes. As the scientist carefully tunes the dials, the device begins to pick up faint radio waves, whispers from distant places, carried across vast stretches of space and time. These signals, though imperceptible to our ears, are all around us, constantly flowing through the air, waiting to be discovered and translated into something we can experience. Now imagine scaling up this idea to a cosmic level. Instead of a simple radio, NASA scientists use some of the most advanced telescopes and observatories ever built. These incredible instruments are designed to capture not just radio waves, but the entire spectrum of electromagnetic emissions that celestial objects send out. Everything from the gentle hum of radio frequencies to the energetic bursts of X-rays and gamma rays. Each type of emission tells a different story about the universe, revealing secrets about stars, galaxies, black holes, and even the very fabric of space itself. These emissions, which can range from the long, slow waves of radio signals to the rapid, high-energy flickers of X-rays, are invisible to the human eye. But with the help of sophisticated technology, scientists can visualize and analyze this data, transforming it into images, graphs, and most intriguingly, sound. By assigning different pitches, tones, and rhythms to various frequencies and intensities, researchers can create audio representations of cosmic phenomena, turning raw data into a symphony of the stars. This process, known as data sonification, allows us to experience the universe in a completely new way. The electromagnetic waves, once silent and invisible, are now transformed into sound waves that we can actually hear. Each celestial object, from pulsars to nebulae, produces its own unique melody, a cosmic soundtrack shaped by the physics of the universe itself. Engineers and scientists carefully process this data, ensuring that the resulting audio is both scientifically accurate and emotionally resonant. The result is an experience that is as educational as it is awe-inspiring. Whether you're sitting in a planetarium, listening through headphones, or simply closing your eyes and letting the sounds wash over you, you're hearing the universe in a way that was once thought impossible. It's a unique and truly captivating journey, one that connects us to the cosmos and reminds us that even in the silence of space, there is music waiting to be heard. The persistence of the myth of sound in space speaks volumes about our fascination with the cosmos and, honestly, the power of storytelling. Movies and TV shows often employ sound effects to enhance the drama and excitement of space scenes. But while these artistic liberties make for a thrilling cinematic experience, they just don't reflect the reality of the silent universe. Could there be pockets within the vast expanse of space where sound might actually exist? It's a tantalizing question, really. While the vacuum of interstellar space prohibits sound, regions dense with gas and dust, like nebulae, could potentially support the propagation of sound waves. However, the frequencies of these sounds would likely be far beyond the range of human hearing. If we were to encounter other intelligent life forms in the universe, would they perceive sound as we do? It's a question that sparks endless imagination. Perhaps they have evolved to detect and interpret other forms of energy, effectively hearing the universe through a different lens. The truth is as profound as it is simple. Space, for the most part, is a realm of profound silence. While we can use technology to translate invisible signals into audible sounds, these are but interpretations, glimpses into the universe's grand symphony translated for our ears. As we continue to explore the cosmos, we do so with a newfound appreciation for the silent beauty of space. And yet we can't help but wonder, what would the universe sound like if we could truly hear its music? This tantalizing question fuels our curiosity and drives us to unravel the universe's mysteries, one silent step at a time.